Okay, now that we have gone through and made our predictions and looked for that pattern, okay, hopefully here's the pattern you noticed, okay. We ended up getting, I'm going to go ahead and I'm going to highlight all my falses. So here's my false, here's a false, here's a false, and here's a false. If you notice, the one thing all the falses have in common, okay, is in this false, I was multiplying by -2. In this false, I was multiplying by -5. In this one, I was dividing by -2, and in this one, I was dividing by -5. And if we look at all the trues, here's a true, 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 true. Here, we are multiplying by 6, multiplying by 3, multiplying by 3, by 2. Okay, so if you notice our falses, we were multiplying or dividing by a negative. Okay, with our trues, we were multiplying or dividing by a positive. So what pattern have we noticed is if we multiplied or divided by a negative, it got us. If we multiply or divide by a negative, the inequality is false. Because what it ends up doing is if I multiply or divide by a negative, we look at here, this multiply by a negative. Let's look at this guy right here. This multiply by a negative right here. Okay, here we've got the negative on the left, a positive on the right. But if we multiply by a -5, now the negative and positive have switched sides, which means that the bigger one is now on the left compared on the right. Okay, so that actually leads us into the multiplication and division properties of equality. So if you multiply, basically our rule is if you multiply or divide by a positive on both sides, you get equivalent inequalities. So you can multiply or divide both sides by the same thing as long as it is positive. Okay, but if you multiply or divide both sides by a negative, the inequality must switch directions because now you have made the other side bigger. Okay, but again, that's only true if you multiply both sides by that negative. Okay, so here, okay, if we want to solve each inequality, so here for this first one, we have x divided by 8 is greater than -5. So I want to solve this for x. So to do that, I have a divide by 8. So to undo the divide, I need to multiply by 8. So I'm going to multiply this side by 8. Even though there's a negative in this problem, I'm multiplying both sides by an 8, which is positive. So since I'm multiplying both sides by the 8, I don't need to worry about switching my inequality. Okay, so x has to be greater than -40. And if so then we want to sketch this. Here's -40. So up here would be 0. We want strictly greater than, so open dot. And we want all numbers that are greater than -40, so it'd be the numbers up here. Okay, so if you're not sure, try a number up here. Okay, I don't know, let's try a number up here, say 16. Okay, so if I take 16 divided by 8, is that going to give me something greater than -5? Sure, it gives me 2. Yep, so it worked. So there's my solution. Because I ended up multiplying both sides by a positive 8. But in this one over here, okay, first off, some of us might be kind of freaked out because our x is on this side. So we know that we can move the x to that side, move the 24 to that side. But to do that, we'll move 3x over here, -24 over here. But then this needs to switch. Since we flip-flopped these, this needs to switch around. Okay, and then to get rid of, I'm multiplying by a 3. So to get rid of a multiply by 3, I'm going to divide both sides by 3. But again, I'm dividing both sides by a 3, not a negative. So these divide out. X is going to be less than or equal to negative 8. Okay, so again, we draw our line. Here's 0. Here's negative 8. We are less than or equal to, so we want a solid dot. We want all the x's less than that, so we want down here. So again, we can always check a number down here. I don't know, maybe negative 10. And let's try it back up into the original here. So we'd have negative 24 is greater than or equal to 3 times negative 10. Oh, negative 24. So is negative 24 greater than or equal to negative 30? Yes, it is. So it worked. There's my solution. Okay, so here, new problem. Again, I think many of us might want to flip-flop those over. You don't have to. You can leave it as is, but we'll have y divided by negative 3, 2. So now this needs to switch. So now we're dividing by a negative 3. So I'm going to have to multiply both sides by a negative 3. But since I multiplied both sides by a negative 3, this thing has to switch direction. So y is less than, negative 3, negative 6. Okay, so here's 0, here's negative 6. Open dot, since we're strictly less than will be down here. So I don't know, let's try a number down here. I don't know, how about negative 12? Try it back up here into the original. So 2 is less than negative 12 divided by negative 3. Is 2 less than positive 12 divided by 4? Yes, 2 is less than 4. It worked. We're good. Okay. Next example. So here we have our y being multiplied by negative 7. So to get rid of a multiply, I have to divide both sides by a negative 7. I'm dividing both sides by a negative. So that means that my inequality has to switch direction. Y is going to be greater than or equal to 35 is 5. Again, draw our line. Here's 0. Here's 5. We want a solid dot because we're greater than up here. Okay, and so let's check. Let's pick a number up here. I don't know, 10 is a nice number. Check it back up here in the original. Negative 7 times 10, is that less than or equal to negative 35? So negative 70, is that less than or equal to negative 35? Yep, it is. It worked. Okay, so any questions on these two? I think that's it. Yeah. Oh, sorry. Ooh. All right, so if you have questions, please come see me. Okay, and good luck on your practice.